Hello, welcome to another class in Signals and Systems. In the previous videos, we discussed about the basic definitions of signal, definition of a system, and we also looked into what do we mean by analog signal processing, digital signal processing. Uh, we also looked into a classification of signals, one of the classification being continuous time and discrete time. Now, in this class, let us discuss another classification of signals that is odd and even signals.
So, a second class of signals is odd and even signals. Okay, so what do we mean by an even signal? Now, the definition of even signal is as follows. For a continuous time case, a signal is said to be even if it satisfies the condition x of minus t is equal to x of t for all values of t. So this is a condition for a continuous time signal being even. So x of minus t will be equal to x of t. That means a flipped version of the signal is itself. For a discrete case, it is x of minus n, flipped version of the signal should be same as x of n. Again, this is for all values of n. So this is how we can categorize a signal into an even signal or not. So let us just take an example, both for a continuous time case and a discrete case. So x of t is as shown here. Let us take this value to be minus 1 and this is plus 1 and the magnitude is 1. So you can see that for all the negative values of t, whatever you have, the same value you have for the positive one. That means the magnitude of the signal remains same irrespective of the sign of the time axis. That means whatever is true at say this value at minus half is true at plus half. So this is a good example for an even signal. For example, see, you can say x at minus half is equal to 1, which is same as x at plus half. And this is true for all the values of t. You can notice that. Coming to a discrete example, so I'll just take, for example, so we'll take this as 0, 1, 2, minus 1, minus 2, and the magnitude of all these samples is 1. So this is x of n. Here again you can see that, for example, x at minus 1 is equal to 1, which is same as x at plus 1. Both the values are same, and it is true for all the values of n. So this is an example for a discrete time even signal. Now let me just take the definition for odd signal. A signal is said to be an odd signal if it satisfies the condition, say x of minus t, if it is equal to minus of x of t for all values of t. This is for continuous case. Similarly, for discrete time signal, x of minus n is same as minus of x of n. again for all values of n. So if this condition is satisfied, the signal is odd signal. Let us take an example. So you can notice here, for all the positive values of t, whatever the signal values are, it is true that at negative values it will be equal to minus of that. What I mean is, see for example in this case, this is the magnitude of the signal, they may be at half, and you can see that at minus half the magnitude is negative of that. So this is negative of, so you can observe that whatever is true at plus value is true, the negative of it is true at the negative value of t. So this is an example. For example, in this case, if you take the amplitude to be say 1, the amplitude is taken to be say 1. So x at half is equal to half because the slope is 1, and you can see that x at minus half is actually equal to minus half. So which satisfies the condition of odd signal. We can also take an example for discrete time. So this is an example for an even signal. This is minus 1, minus 2. Let us take the amplitudes as minus 1 and minus 2. So as you can notice that, say x at plus 1, the magnitude is equal to, sorry, this is plus 1. So x at plus 1, the value is equal to 1. X at minus 1, the value is minus 1. So it satisfies the condition. So this is how we can classify signals into odd and even signals. And usually these even signals are also called symmetric signals. So this is also called symmetric signal. And odd signals are also called asymmetric or antisymmetric signals. This is another nomenclature for odd and even signals. So let us take a typical example and try to solve this problem. So the problem is x of t is equal to a sine omega naught t. You have to verify whether this is an even signal or odd signal. Let us just solve it by using simple steps. So what we need to first do is x of minus t has to be determined. That means wherever I have t, I'll replace it by minus t. And this can be written as a of sine minus of omega naught t. And all of us know that sine of minus of omega naught t is minus sine t, minus sine omega naught t. That means sine of minus theta is minus sine theta. So this will be minus of a sine omega naught t. And you know this is minus of x of t. So it is proved that x of minus t is equal to minus of x of t. So that means sine signal is an example for odd signal. We'll take another example. say x of t is a cos omega naught t. Let us follow the same steps. The x at minus t is a cos of omega naught. Replace t by minus t. And this is a cos minus of omega naught t. And all of us know that cos of minus theta is cos theta. So this is a cos omega naught t, which means x of minus t is same as x of t. So since this is true, your cos signal is an example for even signal. So like this, any given signal, you can expect the signal to be either odd or even, or you can classify it. But that doesn't mean that any given signal belongs to either of these two. There can be a third class of signal which is neither even nor odd. So there can be a signal which can neither be classified as an even signal nor it can be classified as an odd signal. Let me just give you a simple example. Okay, this is an arbitrary signal. You can see that neither the positive values of time amplitudes are same as negative values of time amplitudes. Also, it is not even satisfying the definition of odd signal. So there are signals which can neither be classified into even or odd. However, any given signal, any signal can be decomposed into even part and odd part. So it is possible to uh, decompose a given signal into even part and odd part. So in the next class, let us discuss how we can actually split a given signal into its even part and odd part.